So, good morning, everyone. I welcome you back to my YouTube channel, and presenting before you this wonderful tutorial is the mentor Hamper Kliman. And of course, today I bring you the simplest of the simplest concepts on how to find valence shell electron pair repulsion theory. I'm sure majority of you have seen something like VSEPR, and of course many of you failed to find questions under VSEPR, but I'm going to teach you the simplest way, the simplest on how you are going to make your chemistry simple. Suppose we get a question under VSEPR. Now, there are a few things that I would want you to just know by your heart. Okay? The first one that I would want you to know is simply the possible hybridization that is there under this particular topic. So, the possible hybridization I want you to master this. The possible hybridization. Make sure you know it. So, the possible hybridization is going to come from 2, and it's going to go all the way up to whichever, but up to 6. Okay? And I want you to understand this. So, it's going to range, the one which I'm going to give you. Please understand this one. You write your 2, 3, 4, 5, 6. Okay? This is the simplest one how you're going to know it. Since you are starting from the first one, which is 2, your first hybridization is going to be SP. Right? You are going to 3. The second hybridization you're going to have is SP. Then you're going to include the 2. Because this one is the third, you're going to have SP3. Since you have gone to the third, when it comes to the P's, okay, when you reach the third, that is the end, you're supposed to introduce a D. So on the fifth one, you're going to have SP3, but you introduce a D. See how simple it is? Then on the sixth one, remember that here there is a 1, so you're going to introduce SP3D2. So these are the possible hybridization that you're going to have, and these are very simple for you to understand. They're actually very, very simple. Okay, so make sure you understand them. Now, the second thing I want you to understand is simply the possible molecular shape. The possible molecular shape of a particular atom. So they could ask you what could be the shape, the geometry of the central atom. So please make sure you understand the possible shapes that could ever exist. So let me say possible shapes. Now, what is going to determine the possible shape? The possible shape is going to be determined by the bond, okay, that is in the compound. Bond shape. If you are having a bond of 2, okay, if your compound has got 2 bonds, you expect its shape to be linear. If a compound is having 3 bonds, you expect its shape to be T-shaped. If it's going to have 4 bonds, you expect it to be a square planar. Okay? It's called square planar. if your compound is going to have 5 bonds, then it's going to be called a square pyramid. That is the shape that it's going to have. Square pyramid. Then if it's going to have 6 bonds, then it's going to be called an octahedral shape. Now notice that for the first one, which is simply a bond of 2, you don't even have to master it, because you know that if you're having, let's say carbon, let's say carbon dioxide. Carbon dioxide is going to be presented in this way. You're going to have a carbon atom there, a carbon atom. This is a straight line. So if you're having 2 bonds, this bond and this bond, it becomes linear. So you don't have to master the first one. How about the second one when you're having 3 bonds? Let's say you are having something like this, right? Let's say ammonia. You're going to have a nitrogen here, this hydrogen this side, that hydrogen this side, that hydrogen this side. 3 bonds. What do they make? They make a T-like structure. So when you're having 3 bonds, you have the T shape. How about if you're having 4? Let's say for methane, you're going to have this hydrogen here, the hydrogen there, hydrogen there, hydrogen there. This bond, this bond, this bond, this bond. What do they form? They form a square planar. Okay? This is kind of more like a square. Okay? This is kind of more like a square. So from 2 to 4, you don't have to master them. All you have to know is 5 and 6. If you have 6 bonds, octahedral. If you have 5 bonds, square pyramidal. That's all. Then also know the possible hybridization. Okay? Know the possible hybridization that are there. So that is all you are supposed to understand. If you have got 2 bonds, you expect it to be sp. 3 bonds, sp2. 4 bonds, sp3. 5 bonds, just like that. Okay? So make sure you do understand. But what is going to determine the bond is something that I'm going to show you right now. How are you going to determine the hybridization? You determine the hybridization by a number which I am calling as the steric number. Steric number is calculated using this formula. The number of bonds, okay, so you are going to say the number of bond pairs plus the lone pair. Whatever number that you're going to find here is what you're going to choose the hybridization from. That is where you're going to get the hybridization from. So if you understand just this, then definitely this particular question, this particular topic becomes very simple. Just this. With what we have found here, let's get a question. We see if it's going to be very simple. We have a question which is saying, given the molecular formula for a compound as, okay, we have been given that particular compound, and this is the compound. I will show you slowly but surely on how to solve this using the concept I've given you. look, you're having this particular compound. This compound, what is the central atom for this compound? The central atom where everything is attached is chloride. So you recognize your central atom. Central atom is simply chloride. How many bonds are going to be attached to chloride? The bonds are already here. This number here will give you the number of bonds that are going to be attached to chloride. So of course we expect that 5 of them are going to be attached there. Okay? So you can have this guy, that guy there, that guy there, that guy there, that guy there. You have your F there, your F there, your F, your F, your F. You are going to have 5 bonds. Now, we have established the number of bonds. Let's find the second thing that you're supposed to do is to find the valence number of electrons for the central atom. What is the valency of chlorine? Okay, what is the valency of chlorine? So when you check for chlorine, it is in group 7 of the periodic table. So you expect that it's going to have about 7 electrons in its outermost shell. Okay, 7 electrons in its outermost shell, and it will need 1 electron to become balanced. So the valency of the central atom, okay, the valence of the central atom is simply 7 for chloride, right? You have found the valency for chlorine. Now, since you have found the valence electron of chlorine, what do? This same valence electron for chlorine, you subtract it by the number of bonds. So you're going to subtract it by the number of bonds of chlorine. So you say 7 minus 5, you're going to get a 2, right? These 2 that you have found here, you say you divide it by 2. When you divide it by 2, you're going to get the number of lone pairs. So, number of lone pairs, okay, number of lone pairs, bonds that will be left alone. So you're going, number of lone pairs is going to be, after you subtract your 7 minus 5, the 2 that you're going to remain with, okay, the 2 that you're going to remain with should always, the number that you're going to remain with when you subtract the valency from the number of atoms of that particular compound that you have, okay, you are supposed to divide by 2 always, okay. So number of lone pair, you use this formula, n over 2, where n, so this is the formula you use, where n is equal to the valency of the central atom minus this number of bonds, okay, the number of atoms for the compound, the other atoms that are remaining, okay. So let me just put it as number of atoms there. So I'm sure you understand. Now, we shall be using this concept for everything. So the number of lone pairs is going to equal to 1. Then you say the number of bonds, plus this one gives you the steric number. Remember, the steric pair. So you're going to say this same number of bonds that is here, the 5, because we have 1, 2, 3, 4, 5. So you say 5 plus the number of lone pairs and that is going to give you 6. So this is the steric number based on the formula. Now, the steric number, what is the importance of the steric number? After you find the steric number, look at how simple, guys, this is. You go to what we wrote here. So, because the steric number was 3, the possible hybridization for this particular compound is going to be sp3d2. Okay, so the first question was, okay, let for the sake of teaching. So the possible hybridization for this guy here, possible hybridization is sp3d2. sp2d, sorry, this is 3, 2. That is the possible hybridization. C, predict the possible shape. So for possible shape, how many bonds did we have? 5 bonds. So we had 5 bonds for this particular compound. Then we go on this particular possible shape. So 5 bonds, what are we having? Square pyramidal. So we expect it. We expect this guy to be a square pyramidal. Now the question is saying, the first question, sorry, it's just for the sake of teaching. This is how you do this, okay? The first question is saying, what is the condensed electronic configuration of the central atom? How do you write the condensed electronic configuration of this guy? It's actually very simple. Let me show you. There's a concept that I taught under personal tuitions. I'll be very quick. The first thing that you do, just write your numbers. 1, 2, 3, 4, 5, 6, 7. The second part, it will be a 2. Then you write a 5. Then you repeat the numbers is 3, 3, 4, 4. The third part, from this point here, you are going to write your 4. This at this 4, where there is 5, because it's 5 there. The next one is 6. Then you repeat the numbers in between 4 and 6. It's 5, 5. Then for the fourth column, okay, it's going to be, because the next number from 5 is 6, so you write your 6, then your 7. Then you repeat. These are the S, everything. Then for this one, what are they? You put everything in 2s by starting from the P's. So remember, in 2s, so these ones are the P. Then from the P, where do you go? The D. D. From the D, where do you go? F. Like that. Then again, from the P's, then the D's in 2s. Then again, you go to the P's again, like that. Just like this. Now, you want to find the electronic of the condensed. To find condensed, meaning you are supposed to use the group 8 members of the periodic table. Okay? Those are the ones that you're going to be using. So, let's write first of all the electronic configuration of chloride. Chloride is having a 17 on top, implying that its Z is simply 17. How do you write this electronic configuration? Simple. Get your first S. Your first orbital occupies 2. So you say 2 there. Then you say 17 minus 2. What do you get? You're going to get 15. So remember 15. Then you go in the second row. It's 3S, 3P. This one holds 2. It implies that here 15 minus 2, it's going to be 13. Then if 13 there, this one holds 6, 13 minus 6, we are going to get 13 minus 6, 7. So we're going to get 7. If we put a 6 there, 7, then we go in the third row. Okay? So the third row is 3s, 3p. This one holds 2. If we remove a 2 from 7, we are going to remain with a 5. Then this one holds 6, so we put our 5. That is the electronic configuration of chlorine. Now the question was saying condensed. So we need to check the electronic configuration of the group 8 elements. Okay, so for example, we can start with helium. What is the electronic configuration of helium? Helium is having 2 on top, so its Z is simply 2. So its electronic configuration is simply 1s2. So it doesn't hold. Okay, it doesn't hold. Then we go to neon. Neon is having how many? 10. So its electronic configuration, remember its Z is equal to 10, so electronic configuration will be we have the first S there, which is holding 2, so implying we're going to remain with 8. Then we're going to have 2s, 2p in the second row. Then if we put the s orbitals hold 2, so it implies we're going to remain with 6. Then we're going to have a 6 here. 6 there. So this one is for neon. Okay, then let's write for argon, we see. But, okay, we write for argon for the sake of learning. Implying that Z for argon is going to be 18. So we write 1s, which is this one, it's holding 2. So 18 minus 2. Okay, 18 minus 2. We're going to remain with 16. So here we remain with 16 if I remove 2. Then we go in the second row, it's going to be 2s to the power 2. Then we're going to remain with a 14. Then here we have 2p. The p orbitals hold 6. So we say 14 minus 6, we remain with 8. So if we put 6 there, we remain with 8 of them. Then we go in the third row, which is going to be 3s. 3s holds 2, we remain with 6. 3p holds 6, so we remain with a 6 there. This is the electronic configuration of argon. So when you notice, this one is having a 5, but for argon it's going up to 6, so it can't hold there. But this one is going all the way up to, this one is going all the way up to, let me check, new one is going all the way up to, this is 1s, 2s, 2p. Okay, let me recheck electronic configuration of this guy here, sorry. Let me recheck electronic configuration of chlorine. So we said it's 17, so we start with the 1s holding 2, so 17 minus 2, sorry about that mistake, 17 minus 2, it's 15. So then we go in the second row, it's going to be 2s holding 2. So 15 minus 2, we remain with 13. Then we put our 2p there. 2p can hold 6, so we say if we put 6 there, we say 13 minus 6, we remain with 7. Then we have 3s. If we put a 7 there, we're going to remain with the 5. If we put a 2 here, we remain with 5. Okay, then 3p is going to hold 5. Okay, now it's proper. So if you check, this guy is ending all the way up to 3p, 6, so it can't work. This one is going from 1s 2s, then 2p. It's ending from this, starting from this point up to this point. So you replace that part here there with new one. Then you continue 3s power 2, 3p power 2. That becomes the condensed formula of this particular compound of chlorine. That is the condensed formula. That is how you solve this particular question. You see? It's that simple, guys. It's that simple. Let's try another one, this one. For this one, I'm going to use the same concept. Now I'm going to be very fast. Determine the electronic configuration for this particular guy. So, the central atom, right? Let's determine the electronic configuration of central atom. Bromine. Bromine is having how many electrons? Let me check. Okay, so bromine is having a top number of 35, implying that it's going to be Z is equal to 35. How do you write its electronic configuration? So it's going to be 1s holding 2. Okay, then 2s holding 2, then 2p holding 6. So all these together is what? This is 10. So up to this point we have removed 10. So we say 35 minus 10. So remains 25 in the second row. We go in the third row. The third row having 3s, 3p. So 3s, 3p. So having 25, remaining 25. So this one can hold 2, remaining 23. This one can hold 6. So we say 23 minus 6, remains 17. We go in the fourth row. In the fourth row, having 4s, 3d, 4p. 4s, 3d, 4p. This one holds 2. This one holds 10. So 2 plus 10 is 12. Then we say 17 minus 12, 5. So if we put a 10 here, we have remaining the 5. Then the p holds 6, and then we have a 5 there. So all these together is 5 plus 10 plus 2 plus 6 plus 2 plus 6 plus 4, 35, correct. Now, let's write in its condensed formula. Notice that argon was going up to 6. So, we can replace the entire of this part. We can replace the entire of that part with argon if we want. Okay. So we can say argon there. Then we say okay. Then we say 4s, 2, and then 3d10, 4p, 5. That's its electronic configuration. Now they are saying hybridization. How do we find the hybridization? Simple, guys. What is the valency? The valence of bromine, its valence is simply 7. Then I said you get the valency, the same 7, you subtract it by the atoms. So how many atoms are there? There are 4. So minus 4, it's going to give us a 3. So you get this 3 there. Then you divide it by, let me check, 3 divided by 2. You divide this 3 here. So 3 divided by 2. You're going to get something like 1.5, which you can round off as 2. So these are the number of lone pairs. Okay, lone pairs. Then you are going to say steric number is equal to the number of bonds, therefore, plus the number of lone pairs, which is 2. Then you're going to get 4 plus 2 is going to be 6. So you check. Hybridization is 6. So it's going to be sp3d2. sp3d2. Then what is the shape? The shape is going to be, remember we have 4 bonds, so the shape is a square planar. Simple. That's how you find this thing the simplest. If you found this video interesting and helpful, consider subscribing, hitting the like button, and don't forget to share to others. Thank you so much.